hush lies over the ancient stones. Above, the sky is a frozen ocean, constellations scattered like bioluminescent creatures drifting in the midnight deep, a tapestry as familiar as breath and yet forever unknown. For millennia, humans have lifted their eyes to these patterns, seeking meaning, prophecy, or solace in the cold fires of the night. Even now, in an era of radio telescopes and quantum computations, the question lingers. Might some intelligence, alien and distant, have woven messages into the very patterns of the stars? The possibility is at once exhilarating and humbling, a riddle at the boundary of myth and mathematics, science and longing. The story begins not with a single discovery, but with a yearning as old as civilization. Our ancestors were not content to survive. They sought order in chaos, narrative in the random. Constellations, Orion, Cygnus, the Pleiades were mapped, named, immortalized. The Babylonians charted the heavens on clay tablets. The Chinese mapped supernovae and comets. The Maya tracked Venus to the day. In every culture, a shared conviction. The sky is not merely backdrop, but a language, if only the right mind could decode it. Yet beneath this poetic longing, a scientific hunger took root. The realization that the universe might be comprehensible, that its patterns were not arbitrary, but governed by laws, ignited a revolution. Galileo, with his crude telescope, glimpsed Jupiter's moons and shattered the crystalline spheres of antiquity. Newton, with the calculus, bound the planets to the sun with the invisible leash of gravity. Herschel, with dogged patience, charted nebulae and clusters, revealing a cosmos vaster and more intricate than any had dared dream. Still, behind every advance, the nagging suspicion remained. What if we are not alone? And if there are others, might they have left their mark not in stone or signal, but in the very arrangement of the stars themselves? This is the question that animates a curious alliance, a gathering of astronomers, mathematicians, cryptographers, and mystery hunters. They are united by a conviction that the sky, in all its apparent randomness, may be more than it seems. Patterns, after all, are the grammar of intelligence. DNA encodes life in a four-letter alphabet. Music is a lattice of intervals and rhythms. Mathematics, so far as we can tell, transcends biology, perhaps even space and time. To search for messages in the stars is to walk a tightrope between skepticism and hope. The stakes are nothing less than cosmic. If patterns exist, and if they are not the product of chance or physics, then perhaps, somewhere, someone is speaking, a voice echoing across the gulfs of time and space. But how does one distinguish message from accident, intelligence from natural law? The problem is as daunting as it is intoxicating. The earliest glimmers of this search are almost mythic in their simplicity. In 1899, Nikola Tesla, ever the dreamer, received faint rhythmic signals on his radio apparatus, which he speculated might be extraterrestrial in origin. His claim was met with skepticism, yet it seeded a new ambition, to listen for the artificial in the cosmic. The decades that followed saw the birth of radio astronomy, the first stirrings of what would become the search for extraterrestrial intelligence, SETI. Yet the possibility that messages might be hidden not in electromagnetic signals, but in the very geometry of the heavens, remained largely unexplored. It was in the late 20th century, as computers grew more powerful and data more abundant, that the idea resurfaced with new vigor. The mathematician Carl P. Simon, in a 1974 essay, mused that an advanced civilization might alter the positions of stars, either physically, through engineering on a scale that defies comprehension, or more subtly, by seeding patterns that would only be apparent to sufficiently advanced observers. Others, like the British astronomer Fred Hoyle, speculated on the anthropic principle. If the universe is tuned for life, might it not also be tuned for communication? If so, the stars themselves could bear the fingerprints of intent, a code written in the arrangement of galaxies, clusters, or even the cosmic microwave background. These ideas remained on the fringe, yet they resonated with a certain breed of scientist, those unafraid to court the improbable. The first systematic attempts to test such hypotheses began in the 1980s, as computational power allowed researchers to analyze stellar catalogs for non-randomness. The Yale Bright Star Catalog, the Gliese Catalog of nearby stars, and eventually the vast datasets of the Hipparcos and Gaia missions provided unprecedented maps of the night sky. each star a datum in a cosmic database. One of the earliest and most methodical efforts was undertaken by Dr. Paul Davies, a physicist and astrobiologist whose work straddled the borderlands of science and philosophy. Davies, in a series of papers published between 1981 and 2004, proposed that an advanced civilization might encode information in astronomical phenomena accessible to all technological societies, a cosmic Rosetta Stone. He argued that the isotopic ratios of certain elements, the frequency of pulsar emissions, or the distribution of prime numbers among celestial objects could serve as universal signposts, intelligible to any intelligence capable of basic mathematics. Davies's ideas were rooted in a deep respect for the universality of mathematics. If mathematics is the language of nature, then it is also the only language likely to be shared between civilizations, regardless of biology or culture. The challenge, then, is to find patterns that are both mathematically significant and statistically improbable, patterns that cannot be explained by natural processes alone. The search for such patterns is, in many ways, an exercise in humility. Nature is prolific in its randomness, yet it is also constrained by laws. Gravity, thermodynamics, quantum mechanics. Stars form in clusters, migrate through spiral arms, are shaped by the tides of galactic evolution. The distribution of stars is not uniform, but nor is it arbitrary. The task of distinguishing the artificial from the natural is akin to searching for a single, deliberate brushstroke in a Jackson Pollock painting. Yet the human mind is both blessed and cursed with an appetite for pattern. We see faces in clouds, animals in constellations, messages in noise. This tendency, pareidolia, has fueled both superstition and discovery. The danger is that we might find meaning where none exists, or miss it where it hides in plain sight. To guard against this, the modern search is anchored in statistics. Researchers use sophisticated algorithms to scan stellar catalogs for anomalies, clusters of stars that form geometric shapes, sequences that encode mathematical constants, distributions that deviate from the predictions of stellar dynamics. Each candidate pattern is subjected to rigorous testing. How likely is it to arise by chance? Could it be explained by known processes of star formation and evolution? If not, what might it mean? One of the most famous case studies in this quest is the so-called WOW signal, a burst of radio energy detected by the Big Ear radio telescope in Ohio in 1977. Lasting just 72 seconds, the signal bore all the hallmarks of an artificial source, yet it was never repeated. While not a pattern in the stars per se, the WOW signal became a touchstone for all subsequent searches, a tantalizing hint that the universe might, on rare occasions, whisper secrets to those who listen. But what of the stars themselves? In 2006, a team led by Dr. Eamon Cairns at the University of Manchester conducted a statistical analysis of the distribution of stars in the vicinity of Earth, searching for geometric arrangements that might suggest intentionality, equilateral triangles, pentagons, or other shapes unlikely to arise by chance. Their results were intriguing but inconclusive. While some patterns did appear with greater frequency than expected, the evidence was not strong enough to claim discovery. Randomness, it seemed, was a formidable adversary. Other researchers, inspired by the SETI paradigm, turned their attention to pulsars, rapidly rotating neutron stars that emit clock-like pulses of radiation. In 1974, Jocelyn Bell Burnell and Anthony Hewish discovered the first pulsar, initially nicknaming it LGM-1 for Little Green Men. The regularity of the signals was so striking that artificial origin could not be ruled out until further study revealed natural explanations. Nonetheless, the idea lingered. If one wished to send a message across the stars, pulsars would make ideal beacons, visible across galactic distances, their timing measurable with exquisite precision. In 1999, the astrophysicist Gregory Benford, along with his brother James and nephew Dominic, each a physicist in his own right, proposed that a sufficiently advanced civilization might use the regularity of pulsars to encode information, or even to construct navigational grids on a galactic scale. The Benford's hypothesis, published in the journal Astrobiology, inspired a new wave of inquiry. Could the arrangement or timing of pulsars, or their distribution across the Milky Way, reflect intentional design? To test this, researchers compiled catalogs of known pulsars, hundreds, then thousands. As new surveys came online, they searched for correlations, alignments, or anomalies, patterns that might suggest deliberate placement or modulation. Some tantalizing hints emerged. Certain clusters of pulsars appeared to outline geometric shapes or to repeat specific intervals. Yet, as always, the line between pattern and coincidence proved elusive. The vastness of the data set, coupled with the limited sample size, made definitive conclusions impossible. The search for stellar messages is not confined to radio or visible light. The advent of space-based observatories, Hubble, Chandra, Spitzer, Gaia, has opened new windows onto the cosmos. Infrared surveys reveal the hidden architecture of star-forming regions. X-ray telescopes map the violent deaths of massive suns. Each new wavelength brings new data, new possibilities, new enigmas. In 2015, the Gaia mission, a project of the European Space Agency, began releasing data of unprecedented precision. The positions, motions, and characteristics of over 1 billion stars. For the first time, astronomers could map the Milky Way in 3 dimensions, tracing the intricate filigree of its spiral arms, the subtle warps and ripples of its disk, the ancient streams of stars left behind by cannibalized galaxies. With this flood of data, the search for patterns entered a new era. Teams of researchers, often working independently, sometimes in collaboration, began applying machine learning algorithms to the Gaia catalog, hunting for anomalies invisible to the naked eye. These algorithms, trained on vast libraries of simulated galaxies, could detect clusters, filaments, and voids with superhuman sensitivity. Occasionally, they flagged arrangements of stars that seemed too regular, too geometric, to be the product of chance. Yet, upon closer inspection, these patterns often proved to be artifacts of selection bias, or the result of gravitational interactions spanning millions of years. The difficulty, it became clear, was not in finding patterns, but in proving they were intentional. The universe is a master of both order and chaos. Its laws give rise to structure, yet its processes are indifferent to meaning. To claim a message is to shoulder a burden of proof that is perhaps insurmountable. Yet the search continues, driven by a mixture of scientific rigor and poetic yearning. For some, like Dr. Jill Tarter, co-founder of the SETI Institute and a lifelong advocate for the search for extraterrestrial intelligence, the quest is less about discovery than about expanding the boundaries of the possible. Tarter and her colleagues argue that even negative results are valuable, forcing us to refine our methods, to question our assumptions, to confront the limitations of our own imagination. Others, like the philosopher Nick Bostrom, approach the problem from a different angle. Bostrom's simulation hypothesis suggests that our universe might itself be an artifact, a simulation run by an advanced intelligence. If so, then the patterns we find in the stars might be clues left by our creators, breadcrumbs in a cosmic game. It is a dizzying thought, one that blurs the line between physics and metaphysics, science and science fiction. Outside the halls of academia, the mystery hunters, those who straddle the worlds of science and the paranormal, pursue their own investigations. Groups like the Mutual UFO Network, MUFON, and the Center for the Study of Extraterrestrial Intelligence, CSETI, collect reports of anomalous sightings, strange lights, and patterns in the heavens. Some claim to have decoded messages in the alignments of stars, or to have received communications through dreams or altered states. While these accounts are often dismissed by mainstream science, they testify to a deep and persistent hunger for connection, a longing that transcends evidence or proof. In the digital age, the search has become democratized. Amateur astronomers, equipped with telescopes and software undreamed of by their predecessors, scour the skies for anomalies. Citizen science projects like Galaxy Zoo and Planet Hunters enlist volunteers to sift through mountains of data, flagging objects and patterns that might otherwise go unnoticed. Occasionally, these efforts yield discoveries: a new exoplanet, an unusual variable star, a previously unknown cluster, each a testament to the power of collective curiosity. Yet for every discovery, there are 1,000 false leads. Patterns that seem meaningful at first glance dissolve under scrutiny. Signals that appear artificial are revealed as the product of instrumentation or interference. The process is one of constant iteration, hypothesis, testing, revision, and often disappointment. Still, the question persists, as inexhaustible as the stars themselves. What would constitute proof of a message? Would it be enough to find a geometric arrangement unlikely to arise by chance? A sequence of numbers, prime, Fibonacci, or transcendental, encoded in the positions of stars? A distribution that mirrors the structure of DNA, or the periodic table, or the digits of pi? Each possibility raises new challenges, new standards of evidence. Mathematicians have sought to formalize these questions, developing statistical tools to quantify the likelihood of patterns arising by chance. Bayesian inference, Monte Carlo simulations, information theory, all are marshaled in the quest to separate the signal from the noise. In a landmark paper published in 2012, Dr. Lawrence Doyle of the SETI Institute applied information theoretic analysis to signals from pulsars, seeking to distinguish between natural and artificial sources. Doyle's work, building on the foundations laid by Claude Shannon and Alan Turing, demonstrated that certain statistical signatures, such as high entropy or non-repeating sequences, could serve as markers of intelligence. Yet even with these tools, the problem remains intractable. The universe is vast, its sample size immense, its processes complex and often poorly understood. What appears anomalous in one context may be routine in another. What seems deliberate may be the product of forces we have yet to comprehend. Amid these challenges, some researchers have turned to history for inspiration. They note that the recognition of intent is itself a cognitive leap, a capacity that evolved in humans long before the advent of science. Our ancestors learned to distinguish the purposeful from the accidental, the predator from the prey, the signal from the noise. This ability, honed over millions of years, is both our greatest asset and our greatest liability. It is what allows us to see patterns in the stars, but also what tempts us to mistake randomness for design. To guard against this, the modern search is grounded in a spirit of skepticism. Every potential message is subjected to layers of scrutiny, every pattern interrogated for alternative explanations. The process is slow, painstaking, and often unrewarding. Yet it is the only way to ensure that, if a message is ever found, it will withstand the most rigorous tests of reason. And so the search continues, a dance between hope and doubt, science and poetry. Each new data release, each new algorithm, each new observation is a brushstroke in the unfolding portrait of the cosmos. The patterns we find may be the product of chance, or of laws as yet unknown, or, just possibly, of minds like our own, reaching out across the silence. Some scientists, like Dr. David Kipping at Columbia University, have proposed even more radical possibilities. In 2017, Kipping published a paper exploring the potential for so-called stellar engineering, the manipulation of stars themselves by advanced civilizations. While the energy requirements are staggering, the concept is not entirely fantastical. Freeman Dyson, in his seminal 1960 paper, imagined the construction of vast megastructures, Dyson spheres, to capture the energy of entire stars. If such structures exist, they might alter the star's luminosity, spectrum, or even its apparent position, creating patterns that could be detected by sufficiently sensitive instruments. To date, no convincing evidence of stellar engineering has been found. Yet the search for Dyson spheres and similar anomalies continues, driven by the conviction that the universe is both stranger and more knowable than we can yet imagine. The question of intent, of message, extends beyond astronomy into the realms of philosophy and even theology. If the universe is a text, who is its author? Is meaning intrinsic or imposed by the observer? The search for patterns in the stars is, in this sense, a mirror of our own quest for purpose. We seek in the heavens what we seek in ourselves: order, connection, significance. In this dance of science and yearning, some have found solace in the very act of searching. The astrophysicist Frank Drake, whose eponymous equation attempts to estimate the number of communicative civilizations in the galaxy, once remarked that the search for extraterrestrial intelligence is, above all, an exploration of ourselves. To listen, to watch, to analyze, to hope, these are the hallmarks of intelligence, regardless of outcome. There is a paradox at the heart of this quest. The more we learn about the universe, the more it seems both indifferent and exquisitely tuned. The laws of physics are impersonal, yet they give rise to complexity, beauty, and in at least one corner, consciousness. The patterns we find in the stars may be the product of natural law, yet they speak to us of possibility. For the mystery hunters, the search is both a passion and an obsession. They pore over ancient texts, scan satellite imagery, construct elaborate models of celestial alignments. Some believe that the pyramids of Giza, the Nazca Lines, or Stonehenge encode messages from the stars, or are themselves messages to the stars, a dialogue across millennia. While mainstream archaeology rejects such claims, the allure persists, the belief that the sky is a code, and we its would-be decoders. In recent years, advances in data visualization have allowed researchers to explore stellar patterns in new ways. By projecting the positions of stars onto different planes, or by mapping their motions over time, previously hidden structures emerge: streams, shells, ripples, and arcs. Some of these are the remnants of ancient collisions, others are the signatures of dark matter, or the echoes of primordial turbulence. Yet amid this natural order, the possibility of artifice remains. In 2019, a team at the University of California, Santa Cruz, led by Dr. Raja Guha, used machine learning to identify star clusters that appeared unusually regular, their members spaced with near-perfect uniformity. While subsequent analysis suggested natural explanations, resonances induced by galactic tides, the discovery highlighted the power of new tools to reveal the unexpected. The role of technology in this search cannot be overstated. The rise of artificial intelligence, with its capacity to parse vast datasets and recognize subtle patterns, has revolutionized astronomy. Neural networks trained on simulated galaxies can now flag anomalies with uncanny accuracy, while citizen science platforms harness the collective intelligence of millions. The result is a scientific process that is both more democratized and more powerful than ever before. Yet technology is no substitute for wisdom. The capacity to find patterns is only as valuable as our ability to interpret them. Every candidate message, every anomalous arrangement, must be weighed against the full spectrum of natural explanations. The process is one of perpetual skepticism, a discipline as much philosophical as it is scientific. Amid the rigor, however, there remains a place for wonder. The search for messages in the stars is, at its core, an act of imagination, a willingness to entertain the improbable, to ask questions that may never be answered. It is a testament to the resilience of hope, the persistence of curiosity, the refusal to accept the limits of the known. The search has not been without its controversies. In 2015, the discovery of Tabby's star, a star in the constellation Cygnus that exhibited bizarre fluctuations in brightness, sparked a wave of speculation. Some suggested the presence of alien megastructures, others pointed to clouds of dust or comets. Years of observation, analysis, and debate eventually favored natural explanations. Yet the episode highlighted the hunger for discovery and the readiness of both scientists and the public to entertain radical possibilities. The lesson of Tabby's star and of countless other anomalies is that the universe is more complex than our models, more surprising than our theories. Each apparent pattern is an invitation to look deeper, to question more rigorously, to imagine more boldly. For the scientists who devote their lives to this search, the rewards are often intangible. A new data set, a statistical anomaly, a late-night eureka. These are the milestones of a journey with no guarantee of arrival. Yet the journey itself is its own reward, a testament to the power of curiosity. Among the most eloquent voices in this quest is Dr. Sarah Seeger, an astronomer and planetary scientist at MIT. Seeger's work focuses on the search for exoplanets, worlds orbiting distant stars, and the detection of biosignatures, chemical markers of life. While her research is grounded in the tangible, she has spoken movingly of the emotional dimension of the search, the sense of connection to the cosmos, the thrill of discovery, the humility of confronting the unknown. Seeger's perspective captures the essence of the search for messages in the stars. It is not merely a scientific endeavor, but a human one, a reflection of our deepest aspirations and fears. In seeking patterns, we seek to know ourselves, to find our place in the vastness. The search has inspired not only scientists but artists, writers, and philosophers. The novelist Arthur C. Clarke, in his short story The Sentinel, imagined a message left on the moon, a beacon awaiting discovery by a species mature enough to find it. The idea was later adapted into Stanley Kubrick's film 2001: A Space Odyssey, in which a mysterious monolith serves as both message and catalyst. These fictions capture a truth that science alone cannot: the power of the unknown to inspire wonder. Yet the line between fiction and science is porous. Many of the most outlandish ideas of the past, black holes, neutron stars, gravitational waves, are now established facts. The search for messages in the stars, once dismissed as fantasy, is now a legitimate field of inquiry, however speculative. The future of the search is as open as the sky itself. New telescopes like the Vera C. Rubin Observatory and the James Webb Space Telescope promise to deliver data of unprecedented depth and clarity. Advances in machine learning, data analysis, and simulation will allow researchers to probe the cosmos with ever greater sensitivity. Yet the ultimate challenge remains unchanged: to distinguish the artificial from the natural, the meaningful from the random. The universe is not obliged to be legible. Its patterns may be the product of forces we have yet to imagine. Still, the search continues, buoyed by the hope that somewhere in the vastness a message awaits, an echo of minds as curious as our own, a sign that we are not alone. The search for patterns in the stars is, in the end, a search for meaning. It is an act of faith, not in the religious sense, but in the conviction that the universe is intelligible, that our questions are not in vain. It is a refusal to accept the limits of the known, a willingness to risk failure in pursuit of wonder. For the mystery hunters, the search is a kind of pilgrimage, a journey into the unknown, guided by intuition and fueled by hope. They are the inheritors of a tradition as old as humanity, a tradition that finds its roots in the first stories told around the fire, the first constellations mapped on cave walls. For the scientists, the search is a discipline, a commitment to rigor, skepticism, and the relentless pursuit of truth. They are the heirs of Galileo, Newton, and Herschel, builders of telescopes and authors of equations. For all who gaze upward, the search is a reminder of our smallness and our greatness, our capacity to wonder, to imagine, to seek connection across the void. The patterns in the stars may be the product of chance or of laws as yet unknown, or, just possibly, of intelligence. We may never know for certain. Yet the search itself is a message, written in the language of curiosity, signed by every generation that has dared to look beyond the horizon. In the end, the question is not whether the stars contain a message, but whether we are willing to listen. The act of searching is itself an answer, a declaration that, in a universe vast and silent, meaning is not given, but created. So we continue to look, to listen, to wonder. The night sky is a canvas, and we, its restless interpreters, forever seeking patterns, forever hoping for a sign. Whether or not the stars contain a message, the search affirms that we are, in the words of Carl Sagan, a way for the cosmos to know itself. And perhaps in that search, we have already found the message we seek.